we're gonna go through how to calculate this drops per minute question, or you'll see it written as GTT per minute. GTT means drop. So in this question, the physician ordered ampicillin 950 milligrams every 8 hours. The pharmacy provides 200 mLs to infuse over 2 hours, and the drop factor is 20, and we need to calculate drops per minute. And we're gonna round to the whole number. Before we start, I want to point out the 3 most common things that are missed with drops per minute questions. These are things that tend to throw off students so they end up getting the wrong answer. One is that sometimes we use this phrase drop factor. You just have to know that whenever they give you a number that's a drop factor, that means drops per 1 ml. So in this case, there is 20 drops in 1 ml of fluid. Okay, so that's just something you have to know, and sometimes that'll throw off students and get a wrong answer. The other thing that we have to know is that we have an every and over rule. The rule is always over, never every. So if you ever get 2 different time frames in your problem and you're like, which one am I supposed to use? We always use the one that says over. And we will never use the one that says every. So I'm gonna go ahead and cross this out on our problem. Okay, we will not use that 8 hours. Lastly, the thing that I think is difficult sometimes to understand is that we may not use every number in this problem in our equation, and that's okay. A lot of times in our drop problems, we don't need every piece of information, so don't let that bother you. Okay, let's get started now. So we know that we are solving for drops per minute, so we're gonna write that down. Okay, and I know with my rules of dimensional analysis that whatever I need on top is what's gonna be in my first box. The value on the bottom will come later, so don't worry about filling in minutes at this point, just the GTT or drop. So I'm looking at my problem, and I know from drop factor that there is 20 drops. And then its partner that goes with it on the bottom is 1 ml. Okay, now that we've gotten to this point, I'm gonna cross this out because we've used it. We have ml on the bottom, so we need to put ml on the top. So I go back to my problem. I have 200 milliliters right here. Okay, what is the partner that goes with 200 mLs? Well, the next thing that kind of comes in my problem that's a little bit associated with it is this 2 hours. That's something I could put as a buddy, or I could go back up to this 950 milligrams and put it here. With drops per minute questions, we generally don't care about this dose. We don't use it very often. A good way to kind of double check is if I put milligrams down here, if I put in 950 milligrams, right? And then I tried to keep going, I would have to put milligrams up here to solve my problem. Besides this 950, I don't have anything else that's milligrams, and I don't have anything else that even converts to milligrams. So that would get me stuck. Whenever you get stuck, remember, don't make it up. You just need to go back and see if there's a different number that you need to use. So we are not going to use this 950. Instead, we are going to use our 2 hours as our partner, as our sister. Remember, never, every, always over. So this is the value we choose, 2 hours. Okay, so my mLs cancel. I have hours on the bottom. I need hours on the top. I don't have any more hours in my problem, but I know I need to finish with minute on the bottom. So this is where I can use a conversion to finish. How many minutes are in 1 hour? So 1 hour on top and 60 minutes on the bottom. That allows my hours to cancel, and now I have drops on the top, minutes on the bottom, and that's where I want to be, so I can solve. We're going to do 20 times 200, which equals 4,000. divided by 1 times 2 times 60, which equals 120. Okay, when we divide 4,000 by 120, we get 33.33. Okay, we want to round to the nearest whole number. So this is where I want my number to stop. I'm gonna look at the next door neighbor to figure out to round up or down. Since it is 4 or below, it's going to stay the same. 4 or below, let it go. So my final answer is 33 drops per minute. And that's how we do it.
Okay, so for this next question, we're going to show you the question, give you some time to work on it, and then we'll work on it together. So the question says, an order states 1,000 milligrams every 8 hours. It is infused over 60 minutes. The supply is 50 ml bag and a drop factor of 15. Calculate drops per minute and round to the nearest whole number. So now we'll give you guys a chance to work on it, and then we'll work on it together. Okay, hopefully you've had a chance to work on it, and now let's work on it together. So looking back at this question, it's telling us how the medication is ordered, what is supplied, and then we're asking to solve for the drops per minute. So let's start out with what we're solving for. Drops per minute. Using the always rule of dimensional analysis, we have to start with drops in our boxes. So when I look on here, I see that it says it has a drop factor of 15. A drop factor means that there's 15 drops per 1 ml. So we're gonna have 15 here. And then we know its sister is 1 ml. With my always rule, I have to put ml up here. And then when I look up back at my problem, I'm gonna see where I have milliliters. We have 50 milliliters. Now I have to figure out what 50 milliliters sister is. This can be where it's a little bit tricky because 50 milliliters it's hard to figure out what sister is for the 50 milliliters. So we have a couple different numbers. We have 1,000 milligrams, 8 hours, and 60 minutes. However, the amount of medication that's given doesn't affect what the drops per minute is. We don't need to know how many milligrams is in the medication to know how much we need to be giving or how long it's gonna take for that to be given. Or how often it's being given doesn't determine what our answer is here. But what does determine it is if it's being infused over 60 minutes, then that's gonna help us figure out drops per minute, how many drops per minute they're gonna have. So 50 ml's sister is 60 minutes. When I mark these out, mark out milliliters, we have drops per minute, which is what we need. So we know we're done solving the problem. We don't have to use these two other things. We only need to use these three things in the problem. So when I multiply on top, I get 750. And then when I multiply on bottom, 1 times 60, I get 60. And 750 divided by 60 equals 12.5 drops per minute. And it says round to the nearest whole number. So when we have 12.5, I know that I want to have this 12. I'm gonna look at its neighbor. We have 12.5. If it's 5 and above, give it a shove. So that means that we're going to shove the 2 up to a 3. So it's gonna equal 13 drops per minute.